Good afternoon. My name is Cheryl Sarnes, and today I'm going to walk through the life history and conservation of the snowshoe hare, including what makes this species unique, why it's becoming a concern in some areas, and what can be done to help manage those identification. Risks. The snowshoe hare Lepus americanus is found in boreal and montane forests across North America and is closely tied to cold environment with consistent snow cover. As you can see from the map, its range includes much of Canada, extends into northern U.S. Although the species is currently listed as least concern globally, regional populations, particularly in the areas of Pennsylvania, are experiencing pressures related to habitat change and shorter, less predictable
Moving on to
winters.
identification and morphology, this species has several key adaptations. Seasonal coat color change for camouflage, large hind feet for moving across snow, and long ears for predator detection and thermoregulation. Compared to eastern cottontails, these traits make snowshoe hares highly specialized for snowy environments, but also sensitive to environmental change. Snowshoe hare babies are known as leverts. They are born fully furred and mobile, relying on camouflage rather than parental care. They grow quickly and reach independence early, reducing the time they're vulnerable to predators. This reflects an R-selected strategy: rapid development, early independence, and multiple offspring rather than high survival strategies. Snowshoe hares rely on camouflage, crepuscular activity, and dense understory vegetation to avoid predators. Research shows that removing understory or heavily thinning forest reduces hare abundance, while retaining vegetation supports populations. They also depend on vigilance and quick escape response in predator-rich systems. Reproductive patterns. Snowshoe hares reproduce quickly, breeding from about 1 year old and having 1 to 8 leverets per litter, often multiple times per year. Because offsprings are so independent early, populations can recover despite high predation. This reflects a trade-off: less parental care, but higher reproductive output. Comparison of the snowshoe hare and the eastern cottontail. Habitat. Snowshoe hares are limited to boreal and snowy forests, while cottontails can live in a wide range of environments, including suburban areas. Camouflage. Hares rely on seasonal coat color change, while cottontails remain brown year-round. Predation. Hares experience consistently high predation, especially in systems like the hare-lynx cycle, while cottontails face more variable pressures. Environment dependencies. Snowshoe hares rely heavily on stable snow cover and dense vegetation, while cottontails can adapt to changing conditions. Conservation threats. Factors contributing to conservation concerns. Climate change is a major threat. Reduced snow cover leads to camouflage mismatch between the hare's white winter coat and the surrounding environment, increasing predation risks. Habitat loss and fragmentation also reduce dense vegetation. Local threats. Snowshoe hares in Pennsylvania. In Pennsylvania, snowshoe hares exist at the southern edge of their natural range, meaning populations are already limited in size and highly sensitive to environmental change. Loss of understory reduces both cover and food resources, while shorter winter reduces effective camouflage. Limited dispersal makes these populations especially vulnerable to fragmentation and snowshoe hares in Pennsylvania. The Pennsylvania Game Commission 2024 to 2033 plan focuses on monitoring populations and maintaining habitats. Management emphasizes on dense understory and early successional forest, using selective thinning and retaining patches. Hunting regulations are also adjusted as needed. These strategies aim to stabilize population and reduce predation. My first annotated bibliography is Diefenbach et al. From 2016. The study examined how the distribution of snowshoe hares in Pennsylvania has changed over time using data collected between 1983 and 2011. Researchers used multiple sources, including harvest records, winter track surveys, observation reports, and habitat data. They applied occupancy model and spatial mapping to compare historical and current distributions. The results show a clear range contraction with population now mostly limited to the northern counties and higher elevations. The study suggests that the habitat changes, particularly the loss of dense understory vegetation, along with warming temperatures, are driving this shift, connecting habitat structure and climate conditions directly
Figure shown to the
to
left.
survival
It is a comparison between historical and recent snowshoe hare distributions across Pennsylvania. The different shaded areas represent hares were recorded in the past versus where they are currently found, along with the areas that the data may be limited. What stands out is how much the range contracted over time. Earlier records show snowshoe hares across a much larger portion of the state, while more recent data shows populations concentrated mainly in the northern counties and higher elevations. This reinforces the findings of the study by clearly showing how the species has lost range over time, and it highlights the importance of habitat conditions. From a conservation perspective, this figure helps identify where management efforts should be focused, particularly in areas that still support habitat structure. Bibliography, I
for
used
long-term
Gigliotti
survival.
et al. This study examined how snowshoe hares responded to prescribed burning, which is a forest management technique used to create early successional habitats. Researchers tracked individual hares in northeastern Pennsylvania using radio telemetry and monitored how they used areas that were recently burned several years earlier, and unburned. They also conducted vegetation survey to measure the change in understory density, plant growth, and canopy cover over time. The results showed that the hares avoided recent burned areas because there was very little vegetation to provide cover for predators. However, as time passed, the vegetation began to recover. Those same areas became more suitable. Several years after a burn, dense understory vegetation had developed and hare activity increased significantly. This study highlights how closely snowshoe hares' survival is tied to the vegetation structure. It also shows while disturbance like fire can temporarily reduce habitat quality, they can create beneficial conditions in the long term. From a management perspective, this suggests maintaining a mix of habitat stages across the landscape
shows how the
is
snowshoe
important
hares
for
supporting
activity
stable
change in
populations.
relation to the number of years since the prescribed burn. It compares recently burned areas, older burned areas, and unburned sites. Hare activity is lowest immediately after a burn, which reflects the lack of vegetation and limited cover from predators. As time since the burns increase, activity levels also increase, showing that hares begin to use these areas more as the vegetation regrows. This pattern highlights the importance of the understory vegetation for survival. Right after a disturbance, habitat quality is low, but as the plants recover and the understory becomes denser, the habitat becomes more suitable for both foraging and protection. From a conservation perspective, this figure demonstrates that the habitat management should consider long-term outcomes. A landscape that includes a mix of recently dispersed, recovering, and mature habitats can also provide a range of conditions needed to support. Bibliography is another Gigliotti et al. From 2018. This study looked at how the moonlight affects snowshoe hares' behavior at night, particularly over the movement patterns. Researchers used radio collars to track individual hares and compare how they moved under different levels of lunar illumination. The results showed that the hares clearly adjusted to the behavior based on the bright environment. During the nights where higher moonlight, hares moved less and stayed closer to the dense vegetation, likely to reduce their visibility to predators. On darker nights, they moved more freely and traveled farther while foraging. These findings show that snowshoe hares are constantly balancing the needs for food with the need to avoid predators. This type of behavioral flexibility is important for survival strategy, especially in the environment where pressure is high. From a management perspective, this study highlights the importance of maintaining dense undercover vegetation. Even though hares can adjust their behavior, they can still rely heavily distance change under different levels of moonlight. It compares movement during low, moderate, and high lunar illumination. The overall trend shows that movement decreases as moonlight increases. The brighter conditions, hare move shorter distances, which suggests they are being more cautious to avoid detection by predators. In dark conditions, they move more freely, likely because they are less visible. This pattern provides a clear example of predator avoidance behavior. As visibility increases, hares reduce activity to lower their risk. From a conservation standpoint, this reinforces the importance of habitat structure. Even with behavioral adjustments, hares still depend on dense vegetation for protection. Without adequate cover, their ability to avoid predators, especially under bright conditions, Griffin et al. From 2017. This study examined how pre-commercial thinning affects snowshoe hare populations in young forest in western Montana. Researchers compared three standard types: control, no thinning; standard thinning, PCT; and thinning with retained patches, PCT-R. They measured hare abundance before and after treatment and analyzed the data using repeated measures mixed models. The main finding is that thinning can temporarily reduce hair abundance, especially when the understory is removed completely. Retaining patches of unthinned forest mitigation is effective, provides hairs with shelter and cover. Seasonal differences were also observed, but this critical takeaway is that forest structure strongly influence hair's response. The research demonstrates a clear link between hair life history and forest management because hair rely on dense understory for protection from predators. Management practices needs to account for the importance of the cover. Leaving unthinned patches is an effective strategy to maintain. This table taken from the study summarizes the model results for the hair abundance changes across different thinning treatments. It compares control, PCT, and PCTR, stands over multiple seasons, and shows how each model fits the data. The results clearly show the full thinning reduces hair abundance, while retaining patches lessens that negative impact. Models that included treatment effects, particularly distinguished between PCT and PCTR, fit the data best. For conservation perspective, this table emphasizes the importance of forest management. By retaining patches of unthinned forest, managers can maintain and dense understory hair's need for cover, directly supporting survival and population. My next annotated bibliography is Zimova et al. 2020. This study tracked snowshoe hare coat color changes across 448 camera sites in Canada, Colorado, and New England. Researchers compared molting time with local snow and temperature data to see how environmental conditions influence camouflage. Statistical models were used to estimate the likelihood of hares being fully white or brown at different times of the year. The key finding is that local climate, particularly snow duration, strongly affects molting time. Populations in area with shorter and more variable snow seasons experience higher rate of camouflage mismatch. Hares often remained white under snowless grounds, increasing predation risk. Although there is some variation between regions, hares generally cannot keep pace with a shortened snow season. This study is relevant to the life history and management because it links a critical survival trait, seasonal coat color, to the climate variability. It highlights how changing snow conditions can impact several population dynamics and points to the importance of habitat management strategies that help mitigate. From the study shows proportion of days that hares experienced a white coat mismatch relative to the anomalies in snow cover across Canada, Colorado, and New England. The figure clearly shows that as snow cover decreases, camouflage mismatch increases. This increase in mismatch raises predation risk and can threaten population survival. The figure emphasizes the vulnerability of hares to climate change. For conservation, this reinforces the need to maintain habitat features that provide cover during periods of mismatch and identify populations at highest risk. It demonstrates how climate-driven changes in life history traits directly affect survival and management annotated bibliography. I chose another Zimova et al. From 2014. This study examined whether snowshoe hares could adjust their behavior to compensate for camouflage mismatch caused by changing snow conditions. Researchers monitored coat color, snow cover, and resting site selection at Garden Deer and Sealy Lake, Montana over multiple years. They modeled the probability of hare presence at the resting sites relative to snow cover to assess behavioral responses. The main finding is that hares show limited behavioral plasticity. Although snow cover slightly influenced site selection, the hares did not adjust their behavior enough to reduce predation risk from mismatch. For life history and management, underscores that the behavioral adjustments alone are not study shows the probability of hare presence at resting sites in relation to percentage of snow cover at the Gardenier and Sealy Lake sites in Montana. The figure demonstrates that hares slightly adjust habitat use with changing snow cover, but these adjustments are too limited to mitigate the increased predation risk caused by camouflage mismatch. From a conservation perspective, it emphasizes the need to maintain dense vegetation cover and suitable habitat, rather than rely on natural behavioral adaptation to reduce predation risk and support survival population. Thank you for reviewing this presentation on the snowshoe hare ecology and conservation. These references include all the sources used, highlight key findings, management strategies, and habitat considerations. I appreciate your attention and welcome any questions. Thank you.